What if you gave the reasoning model its own answer and then told it to think about it and improve it? That's exactly what they do here. So in the first round, they just ask the question to the reasoning model. But on the second round, they ask the same question and they also tell it your previous answer was this, and they give it the answer between these tags. And here we can see for QWQ32B, there is an improvement of 3% here on IME 2024. We also see improvements on other benchmarks like GPQA Diamond and LiveBench, and they are usually about 2 to 3% improvements, which is actually a pretty easy gain. You just call it a few more times. They do tests for DeepSeek R1 as well. And here there is a 2% improvement or a bit more. And there is a little bit of improvement here, a little bit of improvement here. Here there is 2.5% improvement as well. Researchers are only giving it previous answer, not previous reasoning steps, so that if it doesn't get stuck on the idea and thought process it had before and the reasoning it got before. And now that it only sees answer, maybe it can come up with a different answer or look at it from a different perspective, but the main point is it's not stuck on the previous way of thinking. This is compared to humans, how we can also get stuck in one way of thinking, and then we need to look it from a different perspective to find a better solution. By the way, you can help me do this full time and teach you all about AI research, science, and engineering. They also counted how many times model uses words like but, wait, maybe. Those are correlated with hesitation and not being certain. And they found that later in the later rounds, the model uses them a lot less, which means the model is more certain. So here we can see each word, but, wait, maybe, therefore. And in round 1, it's used a lot more than in round 2, each of them. And then here we see 4 graphs. First one is when the first answer is incorrect and the second answer is correct. So there is still a reduction in the word but increase in the word wait. Maybe because now it's realizing, wait, this is not correct, let me improve it. And in the end, it improves it. It's also becoming more confident because it's using word maybe less and using word therefore more. Maybe it's concluding like, okay, this is correct, therefore this is correct. Incorrect to incorrect, so both rounds gave incorrect answers. So we just see it's more confident, although this might not be good because now it's just more confident in its incorrect answer. Here it's a lot more confident in correct to correct because the decrease of number of times these words are used is significant for all of them. So if it has a correct answer, it's just gonna become more confident later. And this is a bit crazy. Correct to incorrect. And it's using wait so many times. Maybe it's confusing itself with so many waits. And I'm guessing if it's using wait like 633 times, then maybe the output is also too long, so it just gets confused because of the too long output. Now, is the too long output caused by the confusion, or is the confusion caused by the too long output? I don't know. Maybe we can find if they mention that analysis somewhere below. You see here, increase in word therefore reflects the model's increased confidence in arriving at the correct conclusion. This is also total answer length by round. So first round, for different benchmarks, the answer length is highest, average 10,000 tokens. But for subsequent rounds, for every subsequent round, it's shorter, meaning that the answer is becoming more confident. Now, hopefully, it's becoming more confident in its correct answer, yeah, but we can see here that it's just becoming more confident when you give it its previous answer. Let's look at a different graph. This features IME or AME, this benchmark. This is mathematics benchmark and featuring QWQ32B model. Let's first look at going from round 1 to round 2. So if the answer in the round 1 is correct and the answer in round 2 is also correct, we see the decrease in response length. Now, if the answer is correct in the round 1, but incorrect in round 2, so model performance degraded, we can see big increase in the response length. So the model could be confusing itself and then not understanding what it's doing and then just keep it on rambling. But also, I'm not sure how this is just because of this model. Maybe this model has some flaw, generating like infinite loops or something. But yeah, I don't know the situation here. But going from incorrect to correct or incorrect to incorrect, we can see that the length of output is just decreasing. And the situation is same for other rounds. So only when it's going correct to incorrect, there is more tokens. And here there is a lot more tokens as well. Then they tried using supervised fine-tuning to train the model to go from incorrect answer to correct answer. So they trained it explicitly to rectify previously incorrect answers. They just found math and coding datasets online. Then they just used DeepSeek R1 to generate answers for these datasets, and they generated 100,000 correct answers. If the answer was incorrect, they just discarded it. And they fine-tuned their own model called AM32B. Here are some results. So they are using their model, and the accuracies the first try, accuracies second try without any supervised fine-tuning, it just increased. Now, after the supervised fine-tuning, they taught the model to correct incorrect answers. It actually didn't perform as well as just calling the model again. So I don't know what this means. They could be just like not doing it well, because they say here, although we didn't achieve better performance than just calling it again, this opens up promising directions for future research in leveraging high quality reasoning data to enhance multi-round thinking. So I don't know, maybe they just made a mistake, or there is a deeper problem here. But they say maybe with better data and different better fine-tuning strategies tailored explicitly for iterative reasoning. Yeah, the problem here is, in my experience in the industry, reasoning models are already too slow, and so they are not used too much in like real-time applications. And here you need to call it multiple times, it's gonna be even slower. Here is an example. We have this query, this is question, and it's thinking gives wrong answer, and then you take that answer and you give the same question again, it's thinking again and gives a right answer. We can also check other models here. So DeepSeek R1, I really like these small DeepSeek distilled models, although they are a little bit surpassed maybe by QWQ here, but I really like these models because these models are beating GPT-4o and like a lot bigger models, especially Qwen32B. It's gonna be DeepSeek R1 distilled Qwen32B. Yeah, this one. This model is crazy good, but it's surpassed by this one. But you can see here that every single time you use this technique, it improves by a few percent, like a 0.5% to 3%, all of these scores on every single model. This is some very easy math. So you look at this one. First prompt, you get thinking and answer. Take that answer, you put it here and give the same prompt, exact same prompt. You get thinking 2, answer 2, put the answer into the exact same prompt, answer 2, and you get thinking answer thinking 3, answer 3. And I think it's pretty clear. So I think we completely covered this whole paper and I explained everything. I think there is nothing more. Help me accelerate AI progress and spread benefits AI with free YouTube education by supporting me on Patreon and allowing me to do this full time. See you in the next video.